What we're talking about today is we're still dealing with line segments, but now we're dealing with the actual math that's involved in it. So line segments are going from an endpoint to an endpoint, right? It's not a line. It's a type of line, but it's not a line in general, right? Lines have arrows. This is a line segment. We have a starting and stopping point. We can call these any letters we want. Let's call this P and Q. Right? It's measurable, has a distance. Maybe that's 2 feet, maybe somewhere in that ballpark. If you want to give it a distance. So let's say that's 24 inches. So the book will tend to do that. They'll kind of put the labels in there. They'll kind of just have them floating right above the line. Now, let's talk about how we name it again. It's kind of a good refresher. I know it's called a line segment, but how do you name it? Unlike a homework problem, I said, name the segment that's exactly 2 feet long. How do we write that in the notes? What do you got, Greg?
Isn't it you do the letters?
Yep.
And then you do just line segment or a line without the arrows.
Yeah, that's absolutely right. That's how I write it. That's how you name a segment, right? The letters can go in anywhere, QP, PQ, whatever you have. I always use the endpoints. So even if there's another dot in here, I don't really care. Maybe there's a T in here somewhere. That's fine. Just give me the outside letters if you're talking about that whole segment. If you're talking about the smaller segments, then just list those two. Two letters only, right? Lines you only list with 2 letters. Even though there might be more on there, you just pick 2. And then you put a bar above it. Now, what this actually stands for, like this notation, because that was correct. This stands for the drawing of it. If it wants to talk about the distance, you leave the bar off of it, right? When you leave the bar off, that's talking about the actual 24 inches. If you have the bar on it, it's talking about the actual physical drawing. That's the difference between them. The book interchanges them, so don't feel bad. I don't count it wrong. It's just, I want you to know there is a difference when you put the bar on it and when you don't. So, all right. That was a major part of what we talked about Friday. Is there any questions with the segment idea? Okay, this is like our main topic today. This is the second section of our chapter, right? Chapter 1. It's about line segments and distance. But that's a major part. We're going to come back to this. This is going to be our major focus for pretty much the rest of today. Now, there is one more big piece that we talked about on Friday. We talked about array. That's array. Array has an endpoint, has an arrow on the other side. And I don't care which direction it faces. It doesn't make a difference. But that's array. So this is a line segment or just a segment. Sometimes that's just what they'll say in the book. At the line segment, this is array. Okay, let me put a couple of dots on here. So let's go with like a X, a Y, and a Z. Put some different letters on there. Okay, so how do we name it? We got
Right, X.
Yep.
And Z, and then you put the arrow towards the end that it's pointing to.
Yeah. So point it towards Z, right? The end point's X. That's good. Is there another way we can name it? That was good though. I appreciate that.
ZX with the arrow facing the other way.
Yeah. Yeah, ZX, arrow facing the other way. It's the same name, right? The X is your endpoint. So make sure the endpoint's above X. That was good. I appreciate that. Somebody else now. Another one. There's another name, please.
X and Y and the arrow pointing towards the Y.
Yeah, X, Y, right? You can, with the arrow facing towards Y, because X is your endpoint still. They're all the same. They all mean the same drawing. The arrow has to face the letter it's passing through. The endpoint has to be above the correct, and you have to use X. So nicely done for all 3 of those gentlemen that did that. Okay, any questions with the ray? How we write it? That's the one I'm worried about. This is the one that a lot of people, just from previous years, these are the ones that people get wrong. They have their arrow facing the wrong way. They pick the wrong letters, because they try to mix match or they try to use too many letters. They try to use 3 letters, not just 2. Just little things kind of creep up and you start missing a lot of points. So, but the main part today is like, this is the one we're really focused on. This is the one that most of the section deals with because they like to do measurement and we have a bunch of other stuff we have to talk about that hopefully covered in elementary days, but it's just nice to review some stuff about measurement today. But yeah, so is there any questions from Friday's material that we talked about that you may have a question on, that maybe I went too fast? Because the topics we talked about, if you want to think about it, we talked about line segments, obviously. We talked about arrays. We defined what space is, like three-dimensional space, volume. We talked about coplanar, if you're on the same plane. We talked about collinear, on the same line. Let's see, I don't think there's any other major vocab words. Talked about constructions. We did our first construction drawing, where we copied one segment to another part on your paper, and you had to turn that in for easy points. I think I entered those points in the grade book, so that might be something you already saw in the JMC, for you guys anyway. Okay, but any other questions? I don't want to limit you if you have something that was on your mind. Okay, again, today, this is our focus. We have a couple different things we need to talk about with this. Number one, we have to talk about measurement. Can we put a ruler down? Do you understand how a ruler works? Do you understand how to write answers down with a ruler? Some people are really good. You're in drafting, you're in fabrication classes of some sort, and you've just done it all your life. But some people just never had to use a ruler, right? You never had to use the metric system or the US customary system, and you just need a refresher. It takes like maybe 2 or 3 minutes to do it. So let's take a look. So I'm gonna hand these out, put my little mask on. These are brand new rulers, so don't pull out the little metal bar in them. I'll take these back here today. Don't write on them or anything like that. They even have the little plastic guard on them. Huh. You can tell I've never opened them before. Yeah. Never been out of the package. They're brand new. The first class that ever gets to use them. Okay, everyone's got one. You can take out that little paper sleeve thing. You don't need to have it in there. It's going to be the first ones that pull it off. We're going to throw those away here in a minute. I'll walk around with the trash can. Don't need those. Okay, it's pretty nice. Don't break them. Obviously, they're new. Now, what I want to do today is talk about how to measure with it. I know it seems silly, it seems stupid. It is a basic skill, and I think some people just need a refresher. Maybe you've never done it before. On your paper, on your notebook paper, you don't need to have any separate paper. Just on your notebook, take your straight edge and draw a segment of any length you want. I don't care. Just draw it on your paper, and we'll label it a segment. So it has to have a starting and stopping point. I'll do the same thing. I'll just kind of mimic what you guys are doing. Something like that. We'll call it A to B. Starting and stopping point. You can draw it any length you want. Doesn't have to be small, doesn't have to be big. Just draw one on their paper. This will be kind of our little example today. All right. We're good? All right, now, do we agree that this has a definite starting and stopping point? So it's measurable, right? You physically have the ruler in front of you, right? You drew it. So we could actually measure this. Now, there's 2 types of measurements in front of you. You have it on your ruler. There's the metric system, which is in centimeters and millimeters. So, the metric system. To me, I like the metric system. It's used by 90%, 99% of the planet. I think there's only 3 countries in the whole entire world that don't use the metric system because it goes in base tens. It's really easy. In fact, if you look at your ruler, you'll see why the rest of the world uses it. They're closer together. It's more accurate. Now, granted, there's architectural rulers that you could have that in the customary, the US system, which is in inches, and there's more hash marks, it goes to 30-second scale that are closer even.
You can
but
64ths too.
Yeah, they get really precise, but the metric system is clean, it's easy, and I'll show you why here in a minute. So what I'd like you to do is turn the ruler so the centimeters are at the top. I think it counts up to 30 centimeters, something like that across?
Yeah, 35.
Okay, 35, all right, so here's one of my old, so it counts up to 35. So,
Here's
30.
Is it 30? Mine goes to 35.
Skylar over here.
35?
30.
It says 30.
30.
Goes up to 35. Goes past 30.
Right there's 30.
Yeah, it keeps going like 4 or 5 more hash marks.
Um,
All right. So we gotta measure this, right? So here's the best news. When you measure in centimeters, you're looking for like the major ones. So like 1, 2, and then there's a bunch of hash marks between. Here's the why the metric system's awesome. There's only 10 hash marks. So if you start at like 1 and you count up, there's gonna be 9 hash marks, and the 10th one is number 2. Then you count 9 hash marks, and the next marker would be number 3. That'd be the 10th marker. That's why it's super easy. So if you place your ruler down, so put your ruler down, you need to line up where 0 is, the start, the first hash mark. Don't line up the end of your ruler, line up the first hash mark with A, and then go across, and let's measure. Now, don't pick up your ruler. So I'm gonna do it up here just so you can see it. So I'm gonna do a mock drawing of this. So I'm lining up my ruler, 0 is right here, and you're putting it right up to the line. You don't need to care about, I don't care where A and B is, but line it up right with the dot, and it's gonna count up. So here's 1, here's 2, 1, 2, 3, 4, 5. Let's say it went up to 5, and then it was keep going until it got to 3, right? But let's say it was hitting the 5th hash mark past 2. Okay, let's say that was mine. Well, then the idea is that the measurement of this is 2 centimeters, 5 millimeters, right? Or, and this is the best way of doing it, write it as a decimal. This would be 2.5 centimeters. And yes, this number is directly the decimal, because decimals go in tens. So it's why the metric system is so clean. Whatever the millimeter is, that's exactly the decimal number. So if mine happened to measure 2.4, right, 4 centimeters, this would be 2.4 centimeters. Like it's directly correlated. Does that make sense why the metric system is so clean? It's super easy. Like whatever hash mark it is, that's the decimal you're at. So it's either one. I don't care. I think most people will probably choose this. They just like the decimal form. It's easy to look at. You don't have to think about it too hard. You don't need to write 2 centimeters, 4 millimeters. You can just write 2.4, but it has to be in centimeters. The metric system makes sense. It's easy?
Yes.
Okay, good. Turn the ruler over now. Now we get to mess with the tough stuff. Now we got to mess with the customary system, the U.S. system of measurement. So this is in inches, feet, all that good stuff. I believe yours goes up to 12 inches, correct? And it stops at 12. There's no extras. Now this is the part that is tough for people. You're not used to measuring in the U.S. customary system. Maybe you are. Maybe you've taken some drafting classes or some fabrication class of some sort, and you've had to measure a lot. Maybe you've taken a FCS class where they have you do measurements for quilting and other things. The customary system, the U.S. system, is super messy. It's not clean, and it requires that either you use it a lot and you just get memorizing what the hash marks are, or you count a lot. And so let me explain. So we've lined it up, we've figured out where 0 was for inches, and then you're gonna count up to whatever hash mark you're getting to. Now how this works, I believe mine count up in 16ths. 16ths, yeah. So that's pretty standard for a ruler. So that means there's literally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and the 16th hash mark would be the next inch, right? So there'd be 16 hash marks. Now, obviously, they do a pretty good job of figuring out where the middle is. So 1, 2, 3, 4, 5, 6, 7, 8, and they have a big line right there. That's the half, right? Anyone know why it's half?
It's half an inch.
It's half of an inch, or it's the 8th mark. It's the 8th mark out of 16. That fraction, 8 out of 16, reduces to half because they both have 4s in them. So you divide them both by 4s, you divide them both, or actually you divide them both by 8s, and it turns out to be half. Then there's the other major hash marks. This would be like 1/4, and this would be 3/4. The reason why is because, again, it's what the hash mark is. This is the 4th hash mark out of 16. 4 out of 16, right? It's the 4th marker down the road out of 16 total hash marks. 4 out of 16 reduces to 1/4 because you could divide both 4 and 16 by 4. And that's why it reduces. So here's what I always tell people. If you just count the hash mark and then put a 16 below it, that's your answer. That's the easiest way I can explain it to you, right? So it's like, oh, I'm on the 11th hash mark, it's 11 out of 16. I'm on the 13th hash mark, it's 13 out of 16. That's just what you do. If you happen to get to, let's say this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You get to the 12th out of 16, you're like, ooh, those have numbers in common, like 2's in common, divide them both by 2. And maybe they have more numbers in common. So if I divide 16 and 12 by 2, I get 6 over 8. Ooh, they both have 2 again. So divide them both by 2. Right? It will reduce. Your calculators can reduce those fractions for you. They have a little ABC button. Right? This little ABC button that reduces fractions for you. It tells you what that fraction is if you just type in what it is. Like 13 out of 16, 12 out of 16. It'll reduce it for you. Maybe it doesn't reduce. That's the easiest way I can explain to you. You just count. The other way I can always explain it to you is the big hash marks is the, this is maybe the more confusing way, so if you want to tune out for a second, like you like that method of just counting to 11 over 16, that's fine. Tune me out for a few seconds. The other way that I do this is how I always think of it, is like this is the first big hash mark out of 2 hash marks. The first one, and that's the second one. 2 out of 2. This is the next big hash mark out of 4. 1 out of 4, 2 out of 4, 3 out of 4. Then you go down to the next hash mark. This is the first out of 8. This is the second out of 8. This is the third out of 8. Fourth out of 8. Fifth out of 8. 6 out of 8. 7 out of 8. You use the hash mark sizes to count. You count by like there's 8 big hash marks now. And then obviously this would be the first out of 16 little hash marks, second out of 16, third out of 16. The bottom number is always even, the top numbers are always odds. That's how you can always think of it. Now, maybe you don't like that. It won't hurt my feelings, just count, put 16 on the bottom, you're good to go. Okay, what I'd like you to do is attempt to measure your line in the metric system. And just put it out of 16. Just tell me it's, it's the 10th hash mark out of 16, or maybe you just drew a perfect like 2 inches. That's perfect. I want you to measure what yours is.
In the metric system?
No, with the U.S. system,
Okay.
U.S. customer system, in inches. Sorry, did I say metric system? Oh, sorry, my bad. Measure it with the U.S. system.
2 inches.
So inches, maybe it's 3.5. I don't know. Maybe it's perfect what number you hit. So most people do. It's kind of weird when you first start drawing it, you don't even realize your brain, like when you start drawing it, your brain will stop at certain numbers. So you didn't even do it on purpose. Maybe your brain stopped at like clean 4 inches, like when you're drawing it, or 3.5, or it's just weird how the human brain works when you don't put any thought into something. So, and again, if you need to, count the hash marks and just tell me what the hash mark is out of 16. Now you do have to tell me what inch it is. So maybe you're up, 3 inches, but then you went past a few hash marks. So 3 inches and the fraction after. And it's 4 out of 16. That reduces. All right, questions. Does anyone need help or want to know? What were some of the different numbers we had? Because I'm interested to see how the human brain works. So let's go around the room. What size of the line segment do you have in inches? 3? 3?
2 exactly.
2 exactly?
And
2?
3 and 3 16.
3, okay, that's an odd one. We'll come back
That's
to
was
this.
mine, an odd one.
2 and 13, 16.
Okay, odd again.
2.5.
2.5.
2.
2. 2.
2 and a half.
2.5.
2 and 1/4.
2 1/4. 3/4. 4. Look at this. All right, so there's a few exceptions. Most of the time, and this is weird, I'll do it all day. I'm gonna kind of figure out how many. Most of the time, it's so weird. Like you put the ruler in front of you, and I just told you to draw, and most people just kind of draw. But the human brain, without even thinking about it, will stop you at nice, clean numbers. It'll stop. Like you didn't do it on purpose because I didn't tell you where to stop. But the human brain will go, oh, it's 2, that's 2, and stop. And but rare exceptions. It's odd. That's very weird. So that some people will stop at just a random number, because maybe you didn't look at the ruler, and usually you do. Your brain will catch that. That's why, like when we did the activity on Friday, I gave you that plastic piece of zip strip, because I didn't want your human brain looking at the numbers and stopping at a certain number. because you'll measure it automatically. But it's weird, a lot of 2s, and that'll be the common number all day. And I won't tell people to do that. It'll just be the weird number that people will choose. All right, now, I know that seems odd. The book, the next assignment we're gonna get, we'll probably get an assignment tomorrow. The book will automatically do what I'm like doing on the board. They're gonna give you an object to measure. They're gonna give you an object to measure, and they're gonna have the ruler printed in the book for you. It'll be below the picture, and they just want you to look at the ruler and read off what the number is. Does that make sense? So it's having you practice that idea of measurement. So you know, okay, this is where the hash mark is. Here's what I strongly recommend. Count how many hash marks there are tomorrow. I know you guys are really good at reading rulers and stuff, but count, because sometimes, even if it's a US system measurement, sometimes they don't show all the hash marks. They might only show like 5 hash marks. And so you'll have to put it out of 5. They do some weird stuff in your textbook to see if you really are paying attention to what the measurements are. So maybe they won't count by 16s for the metric system, or for the US system, I should say, sorry. All right, okay, rulers, you can keep them for right now. I'll collect them here in a few minutes. Because I do want to do another activity, so you can just put them off. I don't want to waste any more time for that. All right, so let's go into your notebook. We're gonna draw a segment. So again, if you want to use the straight edge, you can. I mean, it doesn't hurt my feelings. Draw a segment and put a dot somewhere in the middle, kind of like this TPQ idea, but just make it so there's 3 dots and one of the dots is somewhere in there. I don't care. It doesn't have to be in the middle. Just put a 3rd dot inside your segment. It can be any letters you want. So you can call it, I'm going to call mine TPQ. I'm just going to use this example as mine. And I'll get rid of this 24 idea. Okay, you can put the dot anywhere you want. It doesn't have to be the perfect center. It can be off center. It doesn't matter. I don't care where you put it. Okay. Again, make it a segment endpoints. Now, I just need a random number. We're just going to use like centimeters. So somebody just give me a random number. 8. Okay, let's call it 8. So let's say this whole segment is 8 centimeters. So we're going to put that. So I want you to put a little curly brace above it. Say it's 8 centimeters. We're not going to measure it by any means. But let's say it's 8. Okay. Now, if I told you, so now this might be different on your drawing. It's fine. If I told you that this segment right here, from P to T, if this is 6 centimeters, what's TQ?
2 centimeters.
How do you do it?
Just subtract 6 centimeters from 8 centimeters.
Exactly, right? You just do the difference, right? You know the whole thing's 8. To find the missing chunk, if you know this little piece, it has to be the number that adds with 6 to make 8. So you just subtract these. 8 minus 6, this should be 2 centimeters, right? That's going to be one of the major parts of your homework on tomorrow for the textbook. They're going to give you random numbers. They will be decimals, so don't be thrown off by that. They'll give you decimals, and they're going to have you find that missing number, this missing 2 centimeters, or whatever the number is, and it may not be drawn to scale. So maybe they tell you that this is 1.7 centimeters, and they want you to find TQ. This is the mystery number they want you to find. So they want you to find TQ, and that's maybe in the instructions. They want to know what the distance is in centimeters. So don't be like, Ward, that doesn't even look right. I mean, it's telling me on my calculator that it's going to be, 6.3 centimeters. That doesn't look right. That's fine. You're taking 8, you're subtracting 1.7. So no matter what, just trust that that's your number, right? You don't have to show me the work by hand. I'm just showing you what you can do if you didn't have a calculator in front of you. If you haven't already, make sure you are getting a calculator. Make sure you are finding one this week. If you haven't already, make sure you buy one. You'll definitely want one. We're going to be doing a lot of just simple algebraic stuff this week. All right. Questions on the first type of problem they're going to probably show you tomorrow in the textbook. Find the missing number, whatever that number is. And it doesn't have to even match the scale. So, because obviously that doesn't look like 6.3. That looks really small compared to the other ones, so it's not drawn to scale by any means. All right, next thing. All right, next. Okay, so you can do this on the same drawing, you can do it on a different drawing, it doesn't matter. I'm gonna stick with the same kind of picture. It looks terrible, we'll go with it. In your segment, I want you to put a little hash mark right here and a little hash mark right here. And they're not dots. They're actually like little vertical bars that you're gonna put. So add these to your picture if you're gonna draw a new picture. Put those there and there. Does anyone happen to know what those little symbols mean? Maybe you had this in like elementary days or junior high or algebra 1. Does anyone tell you what those little vertical bars are when they're in a drawing like that? Okay. Even though it doesn't look like it, anytime you see this type of figure in your picture, what it's telling you is that the two items that have the same hash mark are the same size. That's telling you that you have what quote unquote congruent segments. That's a new vocab word, congruent segments. The word congruent means, so the definition of the word congruent, because obviously you know what segments are. The definition of a congruent is equal in size, shape, and measure. And think of word, you just repeated yourself like 3 different times. It's a difference in what each word means. So size is proportionality. Are they proportional? Right? You can have a little model car versus the real car. The size is generally the same, right? The tires are the same proportion as the real car. You know, they're scaled down, right? You can have a model of something. The shape is overall the same. Does it look like a car? Does it look like a segment? Does it look like, right? Is it the same shape in general, other than proportionality? And then the measurements have to be identical. That's the kicker. Do they measure to be the same number? So that's the little hash mark. So if we went back to the number that we said earlier, we said this whole segment was 8. This would be 8 centimeters. What would each of those segments have to be then if they're the same size?
4.
4 and 4. This would have to be 4 centimeters. This one over here would also have to be 4 centimeters. The distance from here to here, here to here. And they're not drawn to scale by any means. My drawing looks terrible. But that's the little hash marks mean. So anytime you see it, it could be in this super complicated picture. In fact, I'm going to draw something that the book had that I noticed. Had something like this, where it had items all over the place. It had letters and all that good stuff. And sometimes they're going to have things like this, or double hash marks. Whatever the mark is, those sticks are the same size in the picture. They're congruent segments. So for instance, if I told you that this segment was 7 centimeters, right, that stick right here, this one right here, that's 7 centimeters, then this one down here is also 7 centimeters. You could automatically transfer that knowledge to the other part of the picture. The one with the double hash mark, it doesn't mean 14, it just means this one's matched with the other one up there. So let's say this one's 10 centimeters. Well, then this one's 10 as well. They're just a visual marker to help you tell, okay, these are the same size in the picture. They're supposed to be anyway. All right, questions at all about the drawings? Okay. All right, let's see, we did congruent, we did measurements, talked about segments. Oh, okay. This is my absolute last problem today. Last one. All right. So, And then I'll collect the rulers here in a minute. And I'll have a little trash can around if you need to throw away that little plastic sleeve. All right, draw a segment on your paper. Same thing, put a dot somewhere in the middle, somewhere. It doesn't have to be perfect center. Let's call this one A, B, and C. A, B, and C, where B is somewhere in the interior. It doesn't have to be in the middle. It just has to be somewhere in the inside, somewhere. We'll come back to this. This is going to be our main topic for tomorrow before we get to the homework tomorrow. Hopefully we'll have the online textbook. If I can get the internet working. All right. All right, so here's the idea. This is the idea that they're going to give you in the book. They're going to say this. They're going to say that AB is an x plus 5. BC is 2x plus 3. And AC is, let's say, 24. And the question is, what's BC? This is the question that they ask in the directions. Find the length of BC, the segment. All right. This is the absolute last problem. I think in the homework, I think these are the last 3 or 4 questions. Everything else up to this point was kind of easy. You're measuring a lot, you're kind of comparing, you're figuring out what decimals, where, but then suddenly, bam, they hit you with these. And they're kind of they're out there. I mean, they're so far beyond the other problems, you have to think about what they're giving you. All right, they're giving you each of the pieces. I can draw these are like the numbers that go in the stick. It's like the 8 centimeters and the 1.7 centimeters. They're the length of these objects, right? So x plus 5, this piece right here is AB's length. So that's this piece right here. This is x plus 5. Does that make sense? Yeah. And then BC, this part right here is the 2x plus 3. And then the whole stick is 24. What they're trying to tell you is they're trying to help you set up an Algebra 1 problem. If I were to add both of these pieces together, if this was a truly a line segment, it was a straight line. If I were to add these two together, what would be the total length of this whole stick?
X plus 5 plus x 2x plus 3.
Yes, right? You actually physically add them, right? So I want to know the whole length. He's absolutely right. It's x plus 5 plus 2x plus 3, right? You can physically add them together. And what would they equal? And don't tell me 3x plus 8. What would they equal in terms of total length? 24. They told you the whole stick is 24 in length. They told you that in the instructions. This whole thing is 24 in length. Said equal to 24. And now you have an Algebra 1 problem. Do you see that? You can add the two pieces together to make the whole stick. That's called segment addition. It's called segment addition. You can add pieces together to make a larger stick, but you have to set up the problem on your own. They don't tell you to do it. You have to know that you can do that by labeling the picture and going, okay, I can add these two things together and get, the 3x plus 8. And what would that be equal to? It'd be equal to the number they told me the whole stick is. The whole stick is 24. They told me that. A to C is all 24. So, x, this is 1x. 1x plus 2x is 3x's. 5 and 3 make 8, right? Can I add these two things together? No. One has an x, the other one doesn't. You can't add. And that should equal to 24. Now what?
You can subtract 8 from 24.
Absolutely, right? Subtract 8, right? That's the order of operations. If you don't know the order of operations for solving equations, that's an equation that has an equal sign. Here's a little acronym, if you don't know. I think a word that doesn't look like PEMDAS. Yeah, it's not. It's an equation. It's called SADMAP. Add and subtract first, which you did. You subtracted 8 to both sides. So we did add and subtract first. Perfect. The 8s are gone. This makes, what, 16? Now what? Divided by 3. And whatever that decimal is, that's fine. Divided by 3. x equals whatever 16 divided by 3 is. It's a 5.3 repeating on a calculator. I did that right? 5 1/3. So now, that's x. But did I answer the question? What do they want me to find? BC. BC is that stick right there. It's this piece. To find what this length is, B to C, you have to take the 5.3 and plug it in. So you have to plug it in here. 5.3, plug it into X, and then solve that. That's the idea. If I plug the 5.3 in to X, I have to take 2 times 5.3 repeating, and then add 3 to it. So this ends up being 10.6, and I have to add 3, so this ends up being 13.6 repeating. That's the answer they want. That's the answer that answers the question in the long run. Now, do you see why this is like leaps and bounds beyond any other problems we've done up to this point? It's just like, and here's the weird part. There was no warning. It was like, oh, let's measure things with rulers. Let's, figure out one number that's missing. And so like, bam, they hit you with this thing. And it doesn't make any sense. This is the stuff we're practicing a lot tomorrow. So you know how to do it, you feel comfortable, you want a calculator, that type of thing. All right, I'm gonna walk around, I'm gonna collect my rulers. I'll take the little plastic piece of paper. If you have not turned in your page 8, that is due today, you should get that in like now. So, but I'll walk around and collect.